All right, here is our video lesson for 6.2D maximums and minimums. The warm-up was just over the previous lesson, so we're going to skip that one for the video. We did that one in class. It was over our intercepts lesson. All right, so we are talking today about how to find this point on a parabola, the vertex. So far, we've only done the x and y intercepts, and today we're going to add this one in. So I want you to notice that for these two graphs, the equation right underneath them, the only difference between these two equations is that this one has a negative a value and this one has a positive a value. And you can see how just that change alone really made a difference in the shape and behavior of the graphs. And when I say that the a value is positive or negative, remember what I'm talking about is when compared to our general standard form, ax squared plus bx plus c. In this equation, the a value is 1, and in this equation, the a value is a negative 1. And when the a value is positive, meaning it's greater than 0, then we get this behavior of the graph. We call this opening upwards. And when the a value is negative or less than 0, the graph is opening downwards. Oh, shoot. My brain was somewhere else. When a is negative, the graph opens downward. And then when the graph is opening up, this point, the vertex, happens to also be the lowest point on the graph, and we call that a minimum. Thank you. And when the graph is opening down, then this point, that's the vertex, is the highest point on the graph, and we call that a maximum. And our goal for the rest of the lesson is to identify the vertex points, the ordered pairs, both just by looking at it on the graph and also using math. So on the back, at the very top, we have that the vertex of the parabola is the maximum or minimum of the graph. Also remember that the axis of symmetry is the imaginary line that goes through the vertex. So this dashed line right here goes through the x-coordinate on the vertex. And these are the same graphs and equations from the front of the notes. We're just going to explore them a little bit here. We can find the ordered pair, meaning the x and y values of the vertex both graphically and algebraically. So graphically just means counting from the origin. So remember that an xy ordered pair, the x, you're telling the left and right distance from 0, and for the y, you're telling the vertical or up and down distance from 0. So if I have this vertex here, to get there from 0, I have to go left 2 and down 1. Left 2, down 1. So left 2 is the negative x direction, and down 1 is the negative y direction. And then over here, we're trying to find the xy for that vertex right there. So from the origin, the 0, 0, we have to go right 2 and then up 7. So right 2 is positive direction, and up 7 is also a positive number. So that's how to find the vertex graphically, just using the pictures. Now we're going to find it algebraically. So just pretend now that we don't have the graphs, and we're going to use math to find these answers. And you'll find that the math is going to give us the exact same answer. The math will be mathing. Sorry, I apologize. So here are the steps. First is to determine the A and B values from the quadratic standard form. So this is my equation. So A is the coefficient in front of the x squared, which in this case is 1, and B is the coefficient in front of the x. So in this case, that is 4. So we figured out our A and B, and now we're going to use this formula right here to calculate the x value of our vertex. So this, sometimes you'll hear me call this the vertex formula. On the formula sheet that you'll use for your test, I think it's called axis of symmetry, because it gives us both the x coordinate of the vertex, which also happens to be where the axis, the same place that the axis of symmetry goes through, that x value. So we're going to do that formula, negative b over 2a. So that's negative b, which was 4, over 2 times a, which was 1. So that's negative 4 over 2, and that is negative 2. So that is my x coordinate, and we knew that we were supposed to be getting that because that's what we got when we counted it on the graph. And again, we're doing the math here pretending like we didn't just do it on the graph. These are the steps you would do if you were not given a picture and you had to find it mathematically. So we did step 2, and then step 3, plug the x value from, should say step 2, into the original equation and then solve for the y value. So in the original equation, everywhere I have an x, I'm going to plug that negative 2. So negative 2 squared plus 4 times negative 2 plus 3. Now we're going to follow our PEMDAS order of operations. So I don't have any parentheses that can simplify, so I do exponents next. So I've got negative 2 squared, which means negative 2 times itself. So that's going to be positive 4. And then we do multiplication next, which is right here at the 4 times the negative 2, which is negative 8. And now we do addition subtraction. Remember, that goes left to right. So 4 minus 8 is negative 4, plus 3 is negative 1, which is exactly what we knew we were supposed to be getting from when we counted it on the graph. So mathematically and graphically, you're going to get the same answer. So that's an easy way to verify. All right, I want you to pause the video and do the same steps, but for this equation. So pause the video and do that. Okay, your A value is a negative 1 and your B is positive 4. So here's me plugging that into the vertex formula, negative B over 2 times A. So that's negative 4 over negative 2. Negative divided by negative is positive 2. And then here's where I've taken that positive 2 and plugged it into my equation. And we want to be careful about this negative in front. So this negative, unlike the previous problem, this negative is not being squared. Only the 2 that I plugged in for x is being squared. So following my order of operations, I square the 2, that gives me 4, and then times the negative out front is negative 4. And then we have 4 times 2 is 8, and then we have our plus 3. And then adding and subtracting left to right, we have negative 4 plus 8, positive 4, plus 3 is 7. So my ordered pair is 2, 7, which is exactly the same thing I got on the graphical version.